Hi, my name is Aguayo. I'm a Senior Market Segment Manager for Rogers Corporation. I'm here to talk about an industry trend that we're seeing going on, which is the convergence of the high-speed digital and RF worlds into complex packages. We're seeing this happening in the areas because in the aerospace and defense, as they're trying to achieve more functionality in a smaller package, complex multi-layer boards with RF performance going on beyond the traditional X-band frequencies up to Ku, Ka band, 20, 30, 40 gigahertz. Traditionally, the approaches that people have had before is that they've been working with materials that come more from the high-speed digital world, which is really thinner materials that can be done in very complex multi-layer boards, but they have the drawback of the functionality of that, the performance of these materials, the characterization of them has not been what they need to be and to better understand what they are at 20, 30, 40 gigahertz. Rogers comes from the world of the RF performance in the overall PCB markets world. We see that the high performance materials represent about 10% or less of a $12 billion industry, which is the PCB materials. But that is the RF, high-speed digital, and semiconductor devices materials. So Rogers has recently been working on solutions to be able to provide the designers the performance of the traditional RF materials with the overall ability to do complex multi-layer boards that are needed in this new merging of these two technologies. What does that mean? That means that typically we're seeing people having to do boards that may have 20, 30 layers. They have layers that are working in RF, and some layers are working in high-speed digital. Materials that have to have complex plated through-hole reliability requirements, as well as in-plane flatness requirements. So mechanical properties are very important to match. So in the past, the various suppliers of this industry have come at it from their various strengths. The people who typically provide the epoxy glass materials, the FR4s or the traditional high-speed digital, come from the area of more of the mechanical strength. So where Rogers comes from is from the area of the high-speed, the high-frequency segment. Characterization to the materials well beyond 40 gigahertz, understanding of the impact of humidity and on electrical performance, and now the various thickness options for bond plies, for cores, and something that is new in the industry is low-loss HDI layers. That is something that has been coming into the market requirements more recently, not just in the aerospace and defense, but we're seeing that also in activities that are happening in the 5G markets. So Rogers introduces at the show, has been introducing recently and talking about it at the show at IMS 2018, is the RO4000T product, the RO4835T, which is a low-loss core, the 4450T bomb ply, and we also have the CU4000 copper foils and for HDI layers and foil line constructions, which is something that is new in the RF market. So Rogers has been now approaching this with resins that are very stable versus humidity and that have the performance that is needed in the aerospace and defense industry high reliability market for designers and providing the electrical characterization of such materials for the RF designers so that they can then have all the data they need in their design packages, as they're doing modeling, and be able to speed up the time to market. So that's how Rogers is approaching this convergence of the RF and the high-speed digital and the RF market in the introduction of materials that will address those 2 points. For this, we thank you very much for your time and hope if you have time to swing by the show, come and check us out in our booth. Thank you very much.